Hello and welcome, I'm your Code Monkey. In this lecture we're going to create another scriptable object type. This one is going to be for handling our cutting recipes. So here's our game. I can pick up a tomato, drop it on the cutting counter, cut it, and there you go, slice tomatoes. However, if I could pick up a cabbage, go there, cut it, and there you go, cabbage turns into tomatoes. So we have an obvious issue. The cutting object is currently hard-coded instead of being based on the object we put on top of it. So to solve that, let's make another scriptable object type. Like I mentioned, scriptable objects are excellent for storing and organizing data, so it's perfect for this use case. Basically, we want a scriptable object to hold a reference to the regular object and the cut object, so we can then identify the input in order to spawn the output. Okay, so let's build that. Let's create a brand new C# script, call it the cutting recipe SO, and let's open it. Okay, so now here let's do exactly that, so something extremely simple. So instead of mono behavior, this one is a scriptable object. Let's add the create asset menu. And finally for the fields, let's do just an input and output. So we've got of type kitchen object SO. Let's go for the input and another one for the output. Okay, so that's really it, super simple. Now here in the editor, before we create it, let's keep things organized. So let's make another folder. Let's make it for the cutting recipe SO. And inside, let's right click, create a new cutting recipe. Let's call it tomato to tomato slices. And over here, let's select the reference. So the input is going to be our tomato and the output, the tomato slices. Okay, so this is how we're going to handle things. So let's go ahead and make actually the final kitchen object SOs. So let's make yet another one, a kitchen object SO. Let's make it for the cabbage slices. And then let's have another one for the cheese slices. Okay, so now let's make these. So as usual, let's duplicate tomato, make the cheese slices, and another one for the cabbage slices. Let's go inside of it, and first of all, drag the kitchen object SO. So this one is the cabbage slices. And let's go modify the visual. So instead of this one, the cabbage slices. Okay. So we have this. Let's save the prefab, go outside. Then the other one we made, the cheese slices. So let's swap this out. Let's find the cheese slices and modify the kitchen object SO. Okay. So finally, just assign the references. So on the cheese slices, drag the cheese slices prefab. Let's assign the icon and call it cheese slices. Okay, so finally on the cabbage slices, so these are the cabbage slices. Let's pick up the icon and let's drag the prefab reference. Okay, so far so good. We have created our new icons. And over here, let's just make all of the other cutting recipes. So we've got two more. So one is going to be the cheese block onto cheese slices. And the other one is going to be cabbage onto cabbage slices. So all we need is just to drag drop the scriptable objects. So for this one, cabbage, let's drop the cabbage on the input. Cabbage slices on the output. For the cheese block, that's the cheese block on the input and the cheese slices on the output. Okay, great. All of our data is now stored in some really nice scriptable objects. So now let's go here into our cutting counter. Instead of having a hard-coded kitchen object, let's receive a field of type cutting recipe SO, except we're going to have multiple, so let's actually make an array of this. Call it the cutting recipe SO array. Now for the interaction, this is picking up and dropping things, so let's leave that the same for now. And over here on the alternate, basically we need to find out which recipe we should apply to this. So how I identify that is pretty simple. So we've got the kitchen object that is placed on this object, and we've got a list of cutting recipes, which in turn has the input. So we just need to cycle through all the recipes in order to find the one where the input matches. Okay, so let's go down here, make a function to do just that. Let's make it private. We're going to return a kitchen object SO. Let's call it get output for input. So we give it a certain input and returns the one that matches that one. So it takes a kitchen object SO for the input kitchen object SO. And now here let's cycle. So do a for each cutting recipe SO in the cutting recipe SO array. So let's cycle through all of these and just check if the cutting recipe SO, if this one dot input matches the input that we received. If so, then this is the one we want. So let's return the cutting recipe SO dot output. And to make sure that the function works, down here, let's return null. Okay, so that's it. We give it an input and we get back the output. So now up here, we just need to make sure to do it before we destroy the current kitchen object. So let's store a kitchen object so for the output kitchen object so, and we just get the output from the input, and for the input pass in the get kitchen object, so that's the one inside of this cutting counter, and let's get the kitchen object so. So that gives us the output, and then we just spawn that output. Okay, so that's it. Let's test. Finally, back in the scene, let's just go inside the prefab, and over here on cutting counter, we need to make sure to add all of the recipes. So let's add, so the cabbage, then a second one for the cheese block, and finally for the tomato. Okay, so there are all of our recipes. Let's go outside, save the changes, and let's test. Okay, so over here, let's pick up a tomato, go up there, slice it, there you go, got some tomato slices. Now pick up some cheese, go here, slice it, and there you go, got some cheese slices. And finally the cabbage, go up there, slice it, and there you go, some cabbage slices. All right, awesome. So everything is working perfectly. However, now let's say that I want to pick up some bread, and bread should not really be able to be cut. So if I go ahead and I cut it, and there you go, there's our error. We have no recipe that takes bread as an input, so that obviously leads to a null reference exception. Now here we have two options for solving this problem. One option is simply over here when we do the interact alternate. We get the output for the input, and if this one returns null, then we just don't cut it. So we don't destroy it and we don't spawn it. Or alternatively, we can actually add some validation over here when dropping objects. So we can make sure that we only drop valid cuttable objects. Now both approaches are valid, and actually we do need to implement both of them. We'll see why in a bit. So let's do both, starting off with the validating the drop. So first we check if there's no kitchen object on this cutting counter, then we check if the player is carrying something, and then we drop it from the player on this. So over here, let's just check if there's any recipe that has whatever the player has as an input. So let's go down here, make a function to do that, private, let's return a bool, and call it has recipe with input. And we're going to receive a kitchen object so for the input kitchen object so. And over here, let's do pretty much literally the same logic. So we have this, and if we find a match, then let's return true. So there's a recipe with that input. If not, return false. So now up here, when the player is carrying something, let's check if has recipe with input, and give it the player, get the kitchen object the player is holding, and get the kitchen object so. So if there's any recipe that takes whatever the player is carrying as an input, if so, then we drop it. Okay, so like this, let's test and see if we can drop the bread. Okay, so let's pick up some bread, go ahead, drop it, and nope, does not work. Pick up some cheese, and yep, that one does work. However, now we actually also need the other validation that I mentioned. The reason is because if we place a valid object, like for example the cheese there, so that works, and I can cut it, and yep, that does work. However, now the recipe, the cheese block, became cheese slices, and now cheese slice is no longer an input to any cutting recipe. So now if I try cutting again, yep, there you go, I've got another null reference exception. So we need to validate putting objects on top of it and also actually cutting them. That logic is also pretty simple, so let's go down to the interact alternate. So we just check if there's a kitchen object on the cutting counter, and has recipe input, and let's get this kitchen object, get kitchen object so, just like this. So we're only going to cut if there is a kitchen object here, and it can be cut. Okay, so let's test. So first of all, the other one, let's pick up bread, and nope, cannot drop. Okay, great. Now pick up some cheese, and I can drop. Now interact, cut, now cut again, and yep, there you go, no more errors. All right, awesome. Okay, so here we have everything working perfectly. I can pick up a cabbage, go up there, cut it into slices. I can slice some cheese, and I can even slice some tomatoes. Everything works perfectly. Now, the one thing missing from our design is we don't actually want this action to be instant. We don't want to just press a button, everything slices instantly. Instead, we want to have the player press the button a few times in order to actually cut. So let's do all that in the next lecture.